Okay, everybody, this one is lecture number 7, and it is on Advanced Unix, the C shell. Well, okay, it's a really continuation. If you remember the last weekend you were here, it wasn't too long ago. I think it was February 2nd or so, or 3rd, something like that. 1st or 2nd. Long story short, we started in talking about shells. This is the next lecture that comes at the end of that one. But fortunately for us, there's a little review in the beginning on the shells, so we can pick up where we left off from the last weekend. So the C shell is the focus of this lecture, and it's one of the shells that's available in Unix and Linux. And so the objective of the lecture is to introduce the C shell and concentrate on features not in Bourne, and the Bourne shell, but many are in Bash, which is the shell that you've been using. So here's our background. The C shell was originally part of Berkeley Unix, BSD Unix, and BSD Unix, if you're not familiar with it, is the base system for the Mac operating system. So the OS X is on BSD Unix. So a lot of these commands and a lot of these features can be done on a MacBook, which is why a lot of people, again, like Macs, because you've got Unix underneath it. So, and it's BSD, Berkeley Unix. More tolerant of mistakes than Bourne as a shell, and can avoid accidental logouts and overwrites and stuff like that. It's a stronger, more full-featured shell environment, Unix environment. Easier to configure, history, job control, stuff like that. And some scripting improvements over Bourne. Better variables, arrays, expressions. So there's a lot of different features with the C shell that makes it more popular. Almost all the good things or the good ideas from the C shell have been added to Bash. So here's the problem with these shells. At this point, they're all about the same. So then people go, well, actually, we noticed in class the Bash, I believe, gave us our color coding, where the generic shell didn't give us any color coding. You probably haven't used shells enough to realize what the differences are in terms of the command sets. But in the old days, there used to be more of a difference. Nowadays, most shells support most commands. It's almost like most programming languages have such similar, popular languages have such similar syntax to them. If you compare, let's say, for example, Java syntax with C++ syntax, it's almost the same language. I mean, it's very similar. Or I should say more like C, I guess, but you know, saying integer I and if statements and control statements. And then you start looking at the C shell and you go, well, isn't that just C? Yeah, that's why it's called C shell. That's C syntax. So they go, well, isn't this just like the Bash shell? Yeah, because Bash adopted all of this. So it's kind of like how the MacBook and the PCs are pretty much the same. They all do the same stuff anyway nowadays. Some of them do more than others. Some shells do more than other shells. But they all pretty much can check email. They all pretty much can go on the internet. So, you know, a lot of similarities. Example, history, alias, job control, directory, stacks are all sort of different. So, entering and leaving the C shell. So check for your default shell with PS. As we know, we can type in PS and we can see processes that are running on the system, and you should see your shell named. So if you do that, you'll be able to see. Actually, that's a good test right now. Actually, if I type in PS, I see them in Bash. This is a Bash shell right here. I know it's a Bash shell because it says Bash on it. So if I wanted to change my shell, I can type in CHSH, CHS as an example. And it's going to say unknown user CHS. Unknown, or type in CHS, excuse me. CHSH is the command changing shell for bhacker. So if I type in, or actually I typed that incorrectly, type in CHSH or type in CSH. Change shell is what that stands for. Both commands actually work. If I do this, it says changing shell for bhacker. Put your password in there. I'm going to put my password in there. And then it's going to say, well, what shell did you go to? And it opened up, you know, I've got this temporary thing looking up here. It says changing the password, opening directory, local default. And then I have got office location, shell location, and my default is set to Bash. I can actually change the shell. I'm going to press Control C and exit out of here because I don't really want to do that. But I'm in VI editor actually, so let me go here. There we go. Stopped it out, Control Z'd it. But anyway, this is a utility that allows you to change the shell. What does that mean? instead of opening up bash, I open up a different shell when I log in. So that was a login script that you were looking at, and it changes it for the user. You don't necessarily want to change it for the user, actually. Let me just make sure it didn't change it. I don't think I did, actually, because I didn't edit anything in that file. So it comes up, and I'm still back to bash. So if I change it, I can go into a different one. This is different than typing in another shell and going to another shell. When I type in another shell, I go to another shell on top of my shell. I have two shells open now instead of one. So if I type in PS, I see now I have two shells instead of one. When I enter the shell, I have a single shell. So we can change the shell we enter into. If we don't want to do that, we can just simply change to another shell. Load another shell on top of our shell. Seashells on the seashore. Then, I always have to say that because I can never say it. Then I can go ahead and start running those commands. So SCH is actually TCSH on most Linux versions. The commands are a little bit different. To exit, you type in exit or log out or Control D, maybe. Well, Control Z also logs you out. So if I type in exit, then I'm back to the other shell, and I see I only have bash loaded. So it's kind of interesting how the shells work. And you want to be familiar with shells, obviously, for the final. But, let's go back to the PowerPoint here. History. And actually, as I was mentioning before, bash. Well, born is actually more compatible, but many are in bash as well. So some of these commands, I'm going to try them out in bash. I'm in bash. I know what shell I'm in. You might be in a different shell. If not, type in bash. You can open up a shell if you're telnetting into the server. I think the server's got a different, I think it has a different default shell, actually. I don't think it uses bash.
No, it's not bash.
It's not?
It's
But
not.
you could type in bash, right?
Yeah.
And you can load up bash.
Yeah.
Yeah. So let's say we wanted to use a history here. We can type in history. Let me go back. I want to do it. Everything I'm going to do. I have bash here, so everything I'm going to do in bash because bash is very similar to C shell, and we'll see what happens here. So history shows me my history. And you can see I've done a lot of stuff here in the last couple of days or whatever. I have 504 commands. The last command I typed in was history. So history is the word. You type it in. That's a lot of stuff to look at. So let's say, for example, I want to set the history. So I only want to record 25 events. I can go set history equal to 25. And we know we can type in ENV. Oops. ENV. And we can see our environment. In here, there's a history setting. And I don't even see it in here, actually. But by default, we can set, history equals to 25. And we got an argument here that's needed. Numeric argument required. Probably. Let's take a look here. Set. Did I type in set? Nope, I didn't type in set. So I just typed in history. Well, no, that's if I were in C, that would work just fine. But let's say set history equals to 25. Now I can echo out history, and I can say nothing. Because it's not something that's a command. It's an environment variable that I set. So it's not going to say 25. It's going to, what's history? Nothing. But I set history to 25. So if I type in history, I should have, well, I have more than that. Because I didn't clear my history. If I cleared my history was already more than 25. If I cleared my history, then I could set the history at a maximum, and then I'd only, the next time I started recording history, I'd only see 25. So remember, 20 events after logout is another one. So I can set save history to equal 20. If I save history to equal 20, and let's just go here, set save history equals 20. Then I can log out. Oops, and my terminal window is going to shut on me. But I have more than that. I've never cleared it. I have more than that in here. Type in history and I should come back. This isn't going to do it for me because I still have, I'd have to clear my history out actually. So using the history list. So to execute the last command, I think they used to call this a bang bang. But let's see. We go here. There we go. My last command was clear. If I type in clear, and if I go like this, it's going to do clear again. So I've done a bang bang on it. It was called a bang bang on one of your assignments, by the way. So then we can execute the event number, and we have a number. How about 3, 4, 5, 6? Who's going to keep track of that? Nobody's going to keep track of that. However, if you were writing a script, and this lecture is about scripting, by the way. If you're writing a script, and you know the order in which you're running these commands, you clear the history, you save the history, you're organizing your history, why have to type in the same thing all over again? It's almost like the old-fashioned go-to. You just go back to somewhere. Let's go back to command number 3 and load number 3 again. So you can actually loop, go back, loop, go back, go back, go back, and you can just keep running the same command all over again without even having to type the command in. So just remember, history is a very good way of automating a few things. Yeah, pretty much have to organize the order that you're typing the commands in. You have to be in control of the history there. So you can execute the most recent command that starts with a sequence. So as an example, the most recent GCC or the most recent LOC or something. So initial text doesn't have to be the whole text, just the initial text. So if I have something in my history, then let's see. Let's try it out. Actually, I think I have some stuff in that history. I got this one here. This one here, man. The most recent one is trace route. So if I do here, there's my command. It ran trace route for me. So, but how do I know what that one is? Well, let's see. How about echo? No, that's not going to do echo. That's the most recent one here. Here we have a trace route. Oh, I have an NS lookup. There we go. So NS. You don't actually have to have the statement. All you have to know is I ran a lookup. I ran a this, I ran a that. So you don't even have to know, you don't have to complete it. It's like a wildcard is what I'm trying to say. So you don't have to complete the whole statement. So bash history. We saw that. We typed in history. And this is, by the way, just the generic command. So in bash, the last number of commands. Bash supports the same history feature. So you can go history number, history text. But the relevant environment variables, if you hadn't noticed, I said I had to clear it out. I was actually kind of mistaken on that one. It wasn't really clearing out. I'm in the wrong shell. I'm not in the C shell. That history is not going to work for me. Although it didn't give me any error messages. But remember when I typed in the environment here and I looked at it, I didn't see anything in there for history in here. In fact, I don't see anything in here at all. So I have different environment variables that are being set for that. So relevant environmental variables here, the history files, are going to be in the home add.bash history. So I can set the history file size to 500 entries, and then history size. So for the bash shell, I set the history differently. So here's what the problem is that confuses everybody in Unix. They go, oh, the command doesn't work. Well, it didn't work for me. I'm in the wrong shell. Or, how do I know that? How do I know this? And the problem is you always have to go back and reference which shell you have. Where is the environment variable stored? It's kind of like the difference between running Windows 8 and Mavericks, or another operating system. The history, going to be in a different location. Commands are going to be totally different. So this is, although it looks and feels the same, completely different UI. Which is the most ironic thing, because it looks like a command prompt. A command prompt is a command prompt, right? Nope. Completely different user interfaces. So my bash, if I wanted to change my history, I'm not going to have 25, because I can't use that command in this shell to make that happen. I have to actually switch over to the C shell in order for that to happen, and C shell is CSH to get that to happen. This is not happening. I have to change these files down here. I'm not going to change it because I like my settings the way they are right now. But I'd have to change the relevant files for bash if I were going to do that. So in bash, you can modify the prompt to include the history number. You can't do this in the C shell. Why do you want to do that? Because maybe you want to know what line number you're at. So remember the old days when we used to have line numbers? You type stuff in, and then the prompt shows you where you are, what line you're on in your script. So it makes it a little bit easier. That's inside of bash RC. You can set the prompt. So it includes the history. The exclamation point includes the history number. So mine's going to say like 500 and something at this point. Aliases. These come in handy in shell scripting. Define new commands by using string substitutions. So alias, new command, executed commands. So you don't want to type in you don't want to type in ls minus lg. Then you type in an alias, and you call the alias ll. So actually, I wonder if this would work. Nope, that's not going to work. I was going to say I was going to cut and paste. I'm a lazy typist. You know, I'm going to make the screen a little bit smaller, though, because it keeps scrolling off. There you go. So if I type in, let's just try this one out here. Alias ls minus lg. It's going to say, oh, that was 1-1. No, but, oh yeah, I typed in 1-1. You can't use letters for that. Alright. You can't define it in this shell. I'm in the wrong shell. This is a... Now I'm in C shell. Let's try this again. And you have to also understand I'm on a different dialect of Unix. So I'm on BSD. So depends on BSD C shell versus BSD bash shell. Different than other Unix or Linux versions of the bash or the C shell. Oddest thing. But you just see what happened here? I typed in alias and I went 1-1. Well, that I thought was the problem. It wasn't really the problem. It was the fact that this command is not supported in bash. So I switched it over to the C shell. Now the command works just fine. Part of the problem, and I had an assignment that did this actually, and I took the assignment out of your homework because, oh my god, the administrative overhead of that assignment was ridiculous. Students, the command doesn't work. The command doesn't work. I'm like, oh, switch your shell. But the command doesn't work. And then you go, oh no. Long story short, it's a terrible thing to have to provide support for. Because everyone, you just notice here, I could type this 1,000 times over again. But if you're smart, you know, maybe it's the shell. So I think I've made my point here. When in doubt, switch the shell. The command will probably work. So now I'm actually in a C shell. So when I start typing these C shell commands, I can actually limit my history now. So if I type in history, I'm in C shell right now. If I type in history, I see I only have 2 items. Remember the bash shell, I had 205 or so. I had a lot more items. This has fewer items in it. And this alias works, so I could type in LL. And look at that, the command runs. So what can you do? You can come up with a bunch of aliases that you like. Because you don't want to keep typing in this other command here, ls minus lg. It's a lot of switches. Just make an alias out of it. Now I have a new alias. The new alias is just ll. ll does my list the way I want it to do my list. So it's a little handy. Comes in handy. So, alright, so that's the alias. And now we can have here alias mi. It's a move minus I. So alias who date. This is an interesting one. So we know what who does. Who. And we know what date does. Date. So then we can type in, let's just do them both together. So we can go alias who. And then we can put here who. Oops. Date. And you see I put this little opening and closing. Instead of quotation mark, it's a single quotes. Because it's not a string, it's a set of commands. And this is interesting because look what I just did to who. So now I type in who, and I get the date, followed by who. But here's the problem. Remember before when I typed in who, I got who alone. Then I made a new alias, called it who. Now when I type in who, I got the who and the date. I just changed the behavior of who. Not so desirable further down the road if I type in who and I don't want the date. I can remove the alias, yeah. But if I have the alias set, I have to remember to remove the alias when I want to go back to the other command. So aliases are going to overwrite the existing commands that are in the system if you want to. Redefine command is okay. Redefining commands is okay. So we can remove the alias. I'll show you that in a few minutes. But here we have the first argument of the new command syntax, along with all of the other arguments. So argument substitution. So we can substitute arguments in when we run the command, just like we put switches in for ls. So here's an alias called WID, and we're going to go who, and then we're going to fgrep to something, where you're going to have to type something in. So when you run it, you can say with Igor. So it takes a command line prompt, kind of like what we did with echo. Here's the syntax though. We have the first and then all of the arguments. The first argument of the new command, and then we have all the arguments of the new command. If we want to do the asterisk or we want to do the caret sign. Here, actually, my mouse doesn't work when it's in full mode. The caret sign is the first argument. That's all the arguments. So in here we have one argument. Take this argument that you're going to get in from the command line, pass it to grep, and then run a who on it. So who eager is the same way as just saying who with the pipe sign, fgrep Igor. So list the current aliases. You type the word alias. And I'm not going to type in all these commands because it takes too long, but you might find one's interesting. You can play around with it if you get bored. Alias HD checks the HD alias and comes back and says, I don't know, let's see what happens. So I know I have an alias who. So if I typed in alias who, it comes back and says who, colon date. If I say alias me, there's no alias me. So it's not going to work. So let's see, alias HD checks the alias HD, unalias HD. So I can unalias who, and I can go back to the original who if I wanted to. Remove the alias. Alias. She sells those aliases. / ls. Use the original meaning of ls. So remember the who. I can actually get the original meaning of who. Who's still in here. I haven't unaliased it yet, but I can go like this and go who. And then I can get who, the real who. So you can keep them both. You can unalias it. You don't have to worry about reusing the same commands. So bash alias. I remember I was in C shell. If I go back to bash, I'm not going to do it, but if I go back to bash, it works the same way as the commands, as in the C shell that I was just in a few minutes ago. So alias, unalias, and command works. But defining an alias in the .bash sr is different. So we take different syntax to it. So the alias name is equal to a value. So here we have the alias ls is equal to this value. And alias ll is equal to ls minus l. So bash requires this equal sign instead of the syntax we were using before. So I'd have to say equals. So that's the other thing too. So when I first typed in history, I was actually writing it like a bash history. History equals without putting in. Anyway, long story short, the equals, if you're patterned to doing the equals, you probably like the bash shell better than the C shell. C shell doesn't have any equals in it. So you have to figure out what shell am I in. Your H is equal to history 30. You're like, what? That's the alias H. So you can set the history to equal to 30. Aliases that require multiple commands or arguments are defined as functions. Remember, we're in C shell. If you're a C programmer, you'll like this because the syntax is just like C. So here we go. That looks like a function, but there's no return type on the function. So when I say it's just like it, but they're all void. This one's void. There's no return. There's nothing to return. It's a function. It's not in a programming language. It's in a shell environment. So if I said sgrep, and sgrep is equal to ps auxiliary and blah blah blah, right out this entire command. And I have cs, which is a change directory to the first component, and then run an ls. So all I have to do is type in the word sgrep or cs, and I can run a function. So, and that's multiple commands together in an alias, actually. It's an alias because you just created the function for it. So, that comes in handy if you want to elaborate on your C shells that you're creating and you want to actually just create functions that do stuff. Because I can imagine one that says backup, restore, clean up, archive, go through and zip all these folders together and stuff. Oh, I did not actually any questions about archiving, gzip or zip on the final. I'd left that out accidentally. I probably should have added something next time. Job control. So you can move commands between foreground and background and suspend commands, as we've seen before. This comes in handy with scripting, because what if you were in a script and you want to run a job in the background and then move the job from the background to the foreground when something else finishes? Then you can check on the job status and say, well, something ends, bring it to the foreground. So each background job has process ID, as we've seen before. You type in PS and you see the process ID and a job number. So here's a little example. Here you type in spell glossary and you send it to the glossary out. You use that ampersand and puts it in the background. So you probably want to know about foreground and background processes for the final, by the way. So you go date ampersand and puts it in the background. And then GCC big.c and put it in the background. These are background processes. Type in jobs, and you should see jobs is not supported. I don't believe jobs. Let's just see if jobs is supported. Jobs isn't going to give me anything because I don't have the history stored on my BSD system. On the Unix system, you might actually see jobs working. But you'll see running, and you'll see stopped, done. You'll see all a bunch of statuses that are associated with those jobs. So FG, and along with the job number, takes a background job and moves it into the foreground. So you go FG, and then number 2. Which one was number 2? Number 2 is GCC big.c. So you can move from the background to the foreground. How are you going to know which job you got? Well, could parse jobs, text it, parse it, pull one of the elements out of there, and then run it. So, foreground to background. You have something in the foreground, you want to move it to the background. You can Control Z, suspends the job, and puts it in the background. So before, when I was running a command, I hit Control Z. I actually didn't stop the command. I just took it out of the foreground and I stuck it in the background. I think I was running a trace or something. I can't remember what I was running. But that job was still running, actually. So, maybe not the best way of stopping something. I just took it off the foreground so I could have my foreground back. BG resumes the job, background. BG, the job number, resumes the job number, background. So you can suspend a job, and then you can resume a job. So if I were going back to that window where I hit Control Z, I type in BG, it brings it back. So, stop, put the job number in there. Or better yet, kill, put the job number in. Kill kills the job number. What's the difference between stop and kill? The job stopped for TTPY input must be brought to the foreground with foreground first. Then you, in order to stop something, it has to be in the foreground. To kill something, it can be in the foreground or the background. Kill is an immediate kill. You can use kill switches to just, it's writing a file. It's reading from something. It's in the middle of something just to cut you off completely and damage anything you're working with. 999.
Jobs and processes the same or
Jobs and processes are a little bit different. Jobs are giving you the number of the job along with its state, foreground or background. Process is giving you the process IDs. The only difference is that PS gives you process IDs, jobs doesn't give you process IDs. Jobs only gives you job number. And it's sequentially ordered by the way you ran them. Job number 1, job number 2, job number 3. So jobs doesn't.
Process, right?
I'm sorry?
Mash is a process. If I do a PS.
Yeah, you'll see it. But you type in jobs, you're not going to see it on your MacBook, actually. Because the BSD Unix doesn't support jobs. Job control is for moving from foreground to background. We got a stripped down version of BSD, and we're not necessarily running stuff in the background. Everything runs in the foreground. So why would we need jobs? But the command supported, it just doesn't do anything. If you go onto another Unix system and you type in jobs, you're usually controlling what's running on the system. And then if you're the admin, you can see what everybody's running. Oh, I can see I got student this, I got student that. Actually, let me see. Let me type in jobs actually on the, let's see if I can get into the, let's see. I gotta remember my access though. Let's see, I'm in the wrong, let me just open up another shell because I don't want to mess this one up. Let's see, I want to go back to the root SSH login, but, oh, is this our class? Let's see what happens. If it's not, it might be the other class. It gets me in. Jobs. Nope, jobs not going to be supported here either. Well, actually, hello. You know what? Jobs hosed me. You know why? Because we're on a huge shared Amazon server. And it probably tried to run, but I don't have access to anything. We're on a secluded little directory path. Oh, then the shell's not installed. That one's not going to be installed either. That one is. No, but jobs isn't going to run on the server either. The interesting thing is, in a real world, if you were the admin and you typed in jobs and you actually had it configured and it was turned on and working, I could see everybody on the server. I could see all the jobs. Jobs are like programs. Processes are inside of programs. When I want to see my processes or processes on the system, I type in PS and I get process IDs. And status is associated with jobs. So traditionally, both commands really do the same thing. It's the output that you see on the screen that's a little different. If you're going to support something, you're going to support PS. You're not going to support jobs. Because jobs has too much security issues associated with it in terms of whose jobs or who's going to be the owner of those jobs. PS, you get your processes. You're the owner of all those processes because it's looking at it from a process perspective on the entire system. What's running? That's a job. And then you have a running job. Let's say, for example, I'm the admin and I'm running a bunch of jobs, and I'm on a Unix server, and my entry-level admin at the beginning front desk says, you know what, the computer system's running really slow right now. I can't get to my programs. You go, no problem. I log in and I move one of my foreground jobs to the background. Frees up some of the foreground space. Makes it so the admin at the front desk, her system's running faster now. Takes the load off of the foreground, moves it into a lower priority into the background. This happens, believe it or not, all the time. You walk in and you go, oh wow, the system is pretty slow today. Don't worry about it, I can fix it. You just move stuff around. Because you have this management of all the jobs that are running. Because what does an admin do? They're going to have jobs that are running, such as example, port sniffers, or security program, or login management, or scripts for backing up, scripts for restoring. But, you know, the smart admin would run these heavy-duty jobs at night, but sometimes stuff gets scheduled and the time is off, and then it runs in the middle of the day, and then they can suspend the job. Get the job number, suspend the job. So some of the tools use job numbers, they don't use process numbers. Because here's the problem. Process IDs change constantly. You never use the same process ID more than once. How are you going to write a script that works with process IDs? You can't. If you write a script that works with job numbers, you know which job you ran first, you know which one you ran second, you know which one you ran third. And if the admin's complaining about the system running slow, you go, well, you know, the third one was that heavy-duty backup. Let's suspend the third one. So it's just an organizational technique, long story short. However, an admin on a MacBook, do you really have a need to use jobs? Probably not. So you're a single-user system. So multi-user system, jobs comes in a little bit more handy. So same concept, different output. long story short. So foreground versus background, we went through that already. Control Z puts suspense, it puts it into the background. Stopping and killing. Stopping stops something. Kill just destroys it completely and removes it out of memory. You can start and stop. You can kill to remove. So stops foreground. State changes. So the C shell prints a message at the next prompt when the state of a job changes. So you can use notify to make the shell root report a change immediately. Notify me on a job number. So again, it uses the job number. So notify. In fact, I don't think, because we don't have job numbers, I don't think notify on. So let's see. Take a look here. Let's see if I have anything running. Oh, I got some stuff running here. Let's see. Share. Oh, my man's still running in the background of this shell. I put it in the background. I Control Z'd it. All right, so notify. Let's see. I don't think I can do it with the job number, but let's just see. That would be job number 2. No such job. But if I type in jobs, I don't get my jobs. Bummer. Let's see, maybe I got one. No such jobs. I don't have jobs. If I don't have jobs, I don't have job numbers. Not gonna work. But that's actually kind of interesting. I still have man trace running. I got a lot of stuff running in here. Alright, so let's see. That could slow my system down, actually. Eventually, if I had too much stuff running. Home directory shortcut forms. We saw the tilde brings us back. So your home directory is the tilde. So change directory to home directory, you're back to your tilde home directory. And then we have the home directory of the name. So home directory bhacker, home directory AD. So home directory of the name that you're going to type in. So for the usage, you can see cp idea.text space home directory. So move something from one directory into your home directory. Or list the home directory of AD teach. So I think we saw the tilde for the home directory in one of the Unix exercises already. Then we have file completion. You can't remember the file, don't do this on the file. But otherwise you could just type in, I don't remember, just type in the first couple of letters of it. But if I tell you something about a file, type the whole file name in when you do it. Unless you want to be smart. So, you know what? It'll do it for me. Because it will. So you say set file C, switch on file completion. File completion is a feature. I wonder if I can do that on the system, actually. So let's see. Set file C. Okay. And then I can cat out. Well, let's see what kind of files I have in here. I have this one here called readme. Okay. So then I can say, I don't know the name of the file. You just press escape. So you can go cat. I know it starts out RE escape. No, not going to work in this shell window. So press escape key on that. It should complete it for you. My escape isn't working on this window. So let's see what shell I'm in though. I'm in bash. No, I'm in the wrong shell. No, I have another window open. No, that is my window. Let's see. Hold on a second. Nope, I'm in 2 shells now. I was in the right shell. It lets me set it. But hold on a second. Let's just see. Something with a file extension on it. Like, what do I have in here? I might have to create a file. Here's a file. Term2. I think it's capital term 2. Oh, it did work.
You said
I had to actually press it twice in order to get it to work.
You mentioned set file. EC. It's not file.
Oh, did I misspell it? Well, actually, I had it turned on from the other shell, so It did actually work, but I probably mistyped it. Let's see. File completion. And then I have to press it twice, actually. And it's not actually completing it for me because, oh, it is. It's called term 2. Did I misspell that? Online. Here, let's just do it this way. Cat. Actually, let's see. No, let's just do it this way. Nano myfile.txt. I thought that attendance woman was in here. So, cat my file. Oh, I have to press it twice. All right, I have to press it twice. But it does work on my system. But for some reason, maybe because I'm in a shell, in a operating system, it doesn't capture the first escape. I have to hit escape twice. Are we doing attendance? Let me pause this video for a second. Oh, it's okay. Okay, so let me finish up here. So we have the escape. I had to hit escape twice in order for it to work on my system, but it did work as soon as I typed in the right command, actually. But I typed in the command in the other shell that I was in. So, all right. So Control D. So I did Control Z, puts it in the background. Control C interrupts it. Control D for help. Sometimes the tab key works. So ls h asterisk. Then I got h.history, h.text, h.trig01, cat, and then I can say cat help, and then I can go Control D. So Control D for help. Directory stacks. This is an interesting part. So you can store the list of directories you're using on a stack and then go back up and down. We saw this before when we were traversing directories, so this is a little bit of review. Switch between directories by referring to the stack. So we have the home directory, we have the advanced Unix directory, and we have cops_104 directory. So if we say pwd, we get our directory path. And then we can say push D. So we can push something onto the stack or pop something off of the stack. So we can treat the directory history, the directory traversal, like a stack. So we can say push D, push this directory on. So it pushes the directory onto the stack and then do a cd command. So you can go, and cd command changes to the directory. And then now we are in teach / advanced Unix /. And so then we can go pwd. Now we see that we're in this directory that we pushed on. And then we can push D, we can push another directory on. And then if we check the stack, we're in the other directory. So push D pushes something onto the stack. And then push the top directory down. You can push the top directory down to the CD directory and do a CD at the same time, excuse me. So push D, push it down further. So you can move up and down the structure by pushing D, pushing directory down and up the stack. The stack allows you to traverse easily going up and down to change the directories. So it also performs a CD at the same time. So push the top directory down and do a CD. You can go push D. You just no command. You're just doing push D without a directory name, and then checking the paths with pwd. So if you have to have a push, we could pop something off, remove it from the stack. Pop D. So pop D doesn't have any arguments. It's just like a stack from data structures. Put something on, take something off, take something off, take something off. You're taking off the top element. So pop the top element and change the directory to the new top. Because if you take the top element off and you don't change the directory, you're going to have a problem. And in here, if you push down and you don't change down, you're in a different location. So this one, push does a CD, pop does a CD automatically for you. Check the directory, now we've popped off the stack. So we can type in pop D. Other stack commands, dirs. Lists the directories on the stack. So dirs. And then push D plus a number moves the directory and the position number to the top 0 level and CDs to that directory. And the stack is numbered 0, 1, 2, 3. So let's see. I'd have to know my directory structure in order to do this. I'm not going to do it. I'm too lazy. But try it on your own. And you'll see what happens with that one. Pop D plus a number. Pop off the directory at the position number. So pop 1, pop 2, pop 3. If the number is not 0, then there's no change to the present directory. It's not going to do anything. So it's kind of like if it's empty, you can't pop anything out. So. Variables. We have 4 different kinds of variables in Unix that we can use. We have string variables, numeric variables, special forms of user variables, and then we have shell variables. So we can set name is equal to Fred. Include spaces in older C shells. Newer ones, you don't have to put the spaces in there anymore. You could just say set name no space equals no space Fred. So we can set our own variable. Echo name, we've actually done this before, so I don't have to repeat this either. Set gives you a list of variables, and then unset name, remove name is a variable. Set env sets the environment variable. I've been typing in env to retrieve the environment. If I wanted to set an environment variable, I can add an environment variable. If I add an environment variable, I can use the variable. I can set it to username and then use it in my script for something, or use home or something like that. So there's no equal sign with this one, which is weird because that one has an equals and this one doesn't. So in here we say set environment name Fred, echo Fred, or echo name and you get Fred. Set environment unset name, so you can set the environment. Set environment makes the variable visible to any script called from this shell. So any script can use it. So you have global environment variables, and or from the script containing the set environment. Long story short, you want to make a global environment, put it in the environment variables. Set it in the environment. If it's in the environment, it's available to everybody. Any script that's running from that shell can use it. So if you want to do a local one, set a local one. So here's arrays of string variables. So set colors to equal red, green, blue, and orange. No commas. Very similar. Colors is European colors. So colors with an opening and a closing bracket in the syntax. It's not an array, but it is kind of like an array. I mean, it's not an array like in C. The syntax is slightly different, but you're going to set the colors. Echo colors, you get red, green, blue, and orange. Echo colors 3, you're using it like a C array. You say index value 0, 1, 2, 3. You get blue. 0, 1, 2. 0, 1, 2. Well, starting with 1, excuse me, not with 0. 1, 2, 3. Number 3 is blue. If you say colors 2 through 4, you get blue, green, blue, and orange. So you get arrays with that. I did not ask you to set environment variables on the final exam, by the way, so you don't have to worry about this, or using arrays of strings. The shell scripting questions are based on concepts, not syntax or commands, as I mentioned before. Set shapes. I got some empty ones in there. Echo shapes, nothing's going to print out. Shapes 4 is equal to square. Echo shapes 4 square. That's an empty array. Braces. So use the braces to distinguish a variable from the surrounding text. So you got a variable and you want to put one of them in there and you want to print it out. You can set the prefix to equal to Alex. So you set Alex is now called prefix, or he's going to show up. Echo prefix is short for prefix ender. So here we have the opening and the closing bracket around the variable to print out the value of. So Alex is short for Alexander, is what's going to be printing out here. Because we have Alex, and then we have a text string, and so if we want to insert it as a surrounding text string, we use the opening and closing curly brackets. So you can also write prefix ender, opening and closing brackets, to say this is text that we're going to stick in here. So, kind of interesting. Numeric values. So you can use the @ symbol, or the @ command, for variables holding numbers. So @count is equal to 0, sets the count equal to 0. So @'s for numbers, Without the ats, we get strings by default. Remember the space after the at. Actually, that's a good point. You have to put a space after the at symbol. If you don't put a space at, you're not defining a variable, you're doing something else. So echo count, you get 0. If you didn't stick the at in there and you said count is equal to 0, count's really a string, it's not a number. Why do you care about that? Well, if you take that number and you add it with another number, you're going to get concatenation, you're not going to get addition. So if you want addition, you want to use it as a number, then use the at symbol. So you can do at count is going to be equal to 5 plus 2, echo count, you're going to get 7. At result is going to be equal to the count less than 5, echo result, you get 0. At count is equal to the count plus 5. So you get 7 plus 5 essentially, echo count, you get 12. Or you could write count plus equals 5. And then for people who know C, you go, oh, that looks familiar. Yeah, so it uses the C++, the plus symbols, the plus equals, the minus equals, all the little shortcuts you got there. Count plus plus, increment it by 1, so now 12 turns into 13. You don't know C programming, don't worry about it. These commands are not on the final because I excluded anything there where you'd have to know something about programming. So it makes it a little bit easier. Operators. Most of the C numeric operators are supported. So now maybe you're getting the impression why they call this C shell, because it supports C command syntax for the most part. But it's done differently. It's a shell. It's not C programming. So plus, minus, asterisk, relational operators, logical operators, etc. So we have arrays of numeric variables. So we can set ages is equal to 0, 0, 0, 0, 0. At ages 2 is equal to 15. And then at ages 3 is equal to at ages 2 plus 4. We just turned the strings into, the same string array, turned it into numerics by adding the at symbol. Echo ages 3, we get 19, which is right. Echo ages, we get 0, 15, 19, 0, 0. So we have numbers. So it's the same syntax, you just put the at symbol with a space. So now we have the Bourne shell equivalents. These were the C shells that we're looking at. So Bourne shell only has string variables, no numbers. So it uses expression, EXPR, to switch string variables into numbers. So this is one reason why people like C shell, because you can use that at symbol and you got the numbers. Bourne, you don't have the numbers. You got to convert it. So numbers is equal to 5. Number is equal to expression, number plus 2. Treat it like a number. It's in Bourne. So same thing over in the C shell. We have at number is equal to 5, at number is equal to number plus 2. Syntax is a little bit different. So this is still true today. Works just like you could type this in and just do shells and see it work, see it happen. So not all shells are created equal. They don't all support the same commands. They're very similar these days, but they're not all equal. C shell is used for certain reasons. Special forms of user variables. The $sign and the pound variable returns a number of elements in the variable array. How many are in that array? The number sign, kind of logical. It's going to give us the count. The question mark is going to return 1 if the variable is declared 0 if it's not declared. Do we have that one? So we don't have that one. Just the same way as we're checking to see if an alias existed, now we're seeing if the variable existed, or exists. So you can set days to equal Monday, Tuesday, Wednesday, Thursday, Friday. Echo number of days. So what you did is you put in the $sign, and then you put in the pound sign for number, and then days. So days is declared. Echo question mark days? Yes. 1 is declared, 0 is not declared. So you have set the number of days. Unset days takes it out. Days is not declared anymore if you use the question mark. Why do you want that? Because you can do a query, and you can set the query results to something. And if there's nothing in there, there's no query results. So you can you do an SQL query, do an internet query, do something, or ask the user to type something in. The user doesn't type anything in. It's empty. It doesn't exist. So if it's empty, then don't create the variable, and then check, is the variable there? No. Then ask user for their name again. So it's done for a lot of input checking and a lot of routing. So. Shell variables. Shell variables can be initialized in 3 different ways: by the shell, by the environment, and by the user with the set and the set environment. We saw the set and the set environment already. 2 ways for the shell variables. The shell variables that take values. So 2 types of shell variables. One that take values, and shell variables that act as switches. So they have a value of 0 or 1. So you can keep tags, or not counter, but like a switch. Is something turned on? Is something turned off? And then you can check to see, did we turn on incomplete, a complete, sentence complete, or command complete? Is it turned on? Is it turned off? So we can see what we've got set. So shell variables that take values look like this, with the command name, argument 0, or $0, argument 1, or $1, the first element of the argument. So also 2, 3, no upper limit, no need for shifting or anything. Or the arrays. There's some examples of the arrays that take arguments. They take values or arguments. And then we can print out the number of arguments that are in there. Home sets in, it's an environment variable. These are environment variables. Path, environment variable for the path of the user. Status, exit status of the last command. Was it complete? Was it incomplete? And then here's some examples. This is one we just saw a few minutes ago, file C, actually. It turns on file completion. We can type it out, and it'll give us 0 or 1 if file completion is turned on or not. Ignore end of file. Disables the control D as logout. So we can see if that's turned on or off. No clobber, stops file overwriting. So clobbering, to clobber something means to remove it, to take it away or overwrite it. So we can turn that off. Notify, something on there. Are we notifying any of the jobs? So you can set ignore end of off to 0 to 1. You can actually set it to true, false, on or off, 0 or 1, or you can set the value. So automatic scripts. So now that you've written your own scripts, you can put it in your directory. You can actually call your own scripts from your automatic scripts. Automatic scripts happen a couple of different times. The most common is the login. So at login, the C shell executes a range of scripts automatically. We have our login script. Sets our login directories, sets our paths. So .login is the home directory. .C shell RC is the home directory. They're both located in the home directory. They're both scripts. So they're just going to shut the shell and set the login. Why are they all broken out into many different scripts is because you can reuse the scripts. Everybody can have the same login script. Users can change it depending upon your privileges, your login. Then you can change your shell. So you have this script. You're a user and you like this shell better than the other shell, and you want to set your shell to be equal to this shell. Well, you can do that. You put it in the shell script, different than the login script. So you can divide it all out, make some more modular approach to this. Log in and log out have a script. So when you log out, the script can clean up files, close connections, back something up, tell the admin how long you've been there, report your history, copy your history over, just something. So that's going to be in the home directory. Most of the users' files are in your home directory, but they're hidden. They have a little dot in front of them. The dot makes it so you can't see it in an LS. Is that really a security feature? Could be if you change the ownership of those files and you make it, or you change the access rights to the files and you don't give the user the ability to read it, then they can't touch it, but they can execute it. Well, actually you have to read to execute, so that's not going to work, but you could change the write on it so they can't write it. So if you want to prevent your users from messing up their accounts. Otherwise, you can just let them mess up their accounts. So when a shell script is called, the shell will execute the CSRRC script first. So scripts are executed whenever a new window is called in the X window session. Actually, that's a script that runs every time I open up a terminal window. I get a new script, fresh environment that runs. So here's an example of a shell script. So if we typed in, let's say for example, the login script and printed that out to the screen, we can see we have the set environment for the terminal window to VT100. STTY could erase or X kill you, you know, for erasing or changing or not allowing certain commands or making removing stuff. Echo. This is who is on the machine. Print that out. Go who. So only set is needed, not set environment for the login script. So this is the login script .login as an example. So set no clobber, set ignore off, set history. I don't know. Set alias H is for history. Set the path. So here's the log out sample. So a sample of what a log out script would look like. An echo switch off the air conditioner. Sleep 10. So when you log out, it goes, switch off the air conditioner. And then sleep 10 pauses this output for 10 minutes. Or 10 milliseconds, actually. So you can go, oh, make sure to lock the door. Okay. So when you log out, it will help reminders to self. Make sure to shut the door. Turn off the air conditioning. So script programming. Let's take a look here. I'm at 11:46. Let's just take a look here. I just want to see how much left of this. Oh, we got a lot left. We want me to continue? This gets a little dry after a while. I can go through a little bit more, or we can opt for lunch. Your choice. Lunch. I knew you would say that. This is good timing, actually, because at this point what I want to get into is a bunch of commands for looping, for really writing shell scripts. So what I've done right now, let me just recap here, because this is a good break point. Gone over the difference between bash and C shell. What I want to cover after lunch, first thing is going to do is go through the shell scripting commands. So branching, looping, recursion, interrupt handling, a few things about writing scripts to help you make better scripts and using features. So we've gone through variables and setting environment variables, local variables, login variables, and how to make certain commands that are pretty functional in the shell environment. So we'll continue with script programming, which is going to be the writing part of scripts after lunch. So let me stop this video. It's a good break point, actually.